Welcome to our TED Talk. Today we want to talk about perfumes and how something we use in our daily lives has so much to do with chemistry. Perfume comes from the Latin word perfumus, meaning through smoke. Perfume making dates all the way back to 12,000 BC and was first made by a woman named Taputi, who's the world's first recorded chemist. She came up with scent extraction techniques that would serve as the foundation for perfume development. Her techniques and procedures were documented and passed on, with her most innovative and groundbreaking technique being the use of solvents. From ancient times to the present, one function of perfume has remained the same. Enticing smells drew ancient populations in. The burning of incense and aromatic herbs for religious ceremonies, mostly aromatic gums, frankincense, and myrrh gathered from trees, is one of the oldest uses of perfume. It didn't take long for people to realize perfume's romantic potential, and it was used for both seduction and love-making preparation. In addition, ancient Greek medical thinkers used it as an ancient method of aromatherapy, discovering that certain scents could enhance health and vitality. Although it may not seem like it, chemistry plays a huge role in the composition and fragrance of perfumes.
Perfume consists of 78 to 95% ethyl alcohol. Essential oils comprise the remaining ingredients. Ethyl alcohol is most commonly used because it helps the fragrance spread out. The oils contain the notes, the three scents that make up the complex smell of the perfume. Parfum, the most concentrated perfume, is 15 to 25% oil, where cologne is the least concentrated perfume at about 10% oil. The fragrance can be synthesized or can be taken from a plant, animal, etc. Without the perfect combination of the fragrance and base combined, the smell can come across as too strong or too light. Oils are extracted from plant substances by several different methods: steam distillation, solvent extraction, enfleurage, maceration, and expression. In steam distillation, steam is passed through plant material where the essential oil turns into gas. The gas is then passed through tubes, cooled, and then liquefied. In solvent extraction, plants are basically squeezed until the oil releases. The flower parts dissolve in the solvents and leave a waxy material that contains the oil. In enfleurage, flowers are manually removed from wooden frames and changed until the grease has absorbed their fragrance. In maceration, it's very similar to enfleurage, except that warmed fats are used to soak up the flower smell. As in solvent extraction, the grease and fats are dissolved in alcohol to obtain the essential oils. Expression is the oldest and least complex method of extraction. In this process, the fruit or plant is manually or mechanically pressed until the oil is squeezed out.
Esters are very commonly found in plants and are responsible for many distinctive odors and flavors that can be used in perfume. For example, methyl salicylate has the odor and flavor of oil of wintergreen, while propyl ethanoate has that of a pear. Ketones and aldehydes are known for their sweet and sometimes pungent odors, for example, the smell of vanilla extract. They are often pleasant smells from nature and are very appealing to many customers buying perfume. Perfumes are made by mixing aromatic compounds with a solvent, like water or alcohol. The standard dilution is 10% of solvent. Solvent is usually a mix of water and ethanol or alcohol. Different compositions of solute yield different types of perfumes, like perfume extract, esprit de parfum, aftershave or splash, and more. Perfumes contain ingredients from a number of sources, but the vast majority of perfume components are obtained from plants. Approximately 2,000 plant species have been used as sources for perfume materials. As Haley mentioned earlier, the chemicals used in perfumes are extracted through a solvent extraction process in which compounds are separated based on their relative solubilities, or distillation, a purification method for liquids that can separate components of a mixture if they have significantly different boiling points, or other methods. Then the oils are diluted with ethanol or water to varying degrees, getting ready to mix. Also, depending on the price or the finished product, the less ethanol present, meaning that there's a higher percentage of active odor ingredients, the more expensive the perfume.
Perfumes have an appealing smell and can be made from natural resources from the earth, such as lavender or sandalwood oil, but some perfumes are made synthetically in a lab. The chemical group perfumes can be classified as is esters. A common ester in perfume is benzyl acetate, which has a pleasant and sweet smell and is formed from the condensation of benzyl alcohol and acetate acid. The esters in perfume are responsible for determining the physical and chemical properties the substance has. One physical property of perfume is that it does not react with water, which is important for the makeup so that the perfume does not react with perspiration. Another physical property of perfume is that it is generally colorless and has a pleasant smell. Perfume's physical property of smell is designed to have a three-part smell system. The top note smell fades after about 15 minutes, while the middle notes or heart notes last about 20 to 60 minutes and makes up the dominant scent in perfumes. Lastly, the base notes last about 5 to 8 hours and stick to the skin more because it is made from a thick gum material. The density of perfume, another physical property, varies on how strong the scent is and the brand of perfume, so it is hard to determine an overall density. Concentration is more widely used when classifying perfumes because it can make clear how strong the scent will be. The physical properties of melting point and boiling point of perfume vary based on the scent of the perfume. The average melting point is negative 93 degrees Celsius, and the boiling point average is 120 degrees Celsius. One chemical property which is important in perfume due to the chemicals in it is toxicity. Perfumes can contain phthalates, which are chemicals that bring health risks, such as cancer, human reproductive issues, birth defects, endocrine disruption, and respiratory problems with the use of it. Fragrance chemicals can also pass from the skin to the blood. It is important for manufacturers to balance these chemicals and decrease the use of them to avoid toxic properties in perfumes. Perfumes are classified as flammable products because of their makeup, which contains ethyl alcohol. Light can have an effect on the stability bonds in fragrances. UV rays will change the smell of perfume. Oxidation is a catalyst for perfume, so if the oxidation state is changed, it affects the color and how perfumes react on people's skin, which can be dangerous and harmful.
Perfume puts to use one of the most important of the five senses, smell. It includes presence of pheromones, memories the scent invokes, a feeling of escape, and the ability to show individuality through fragrances. As you can see, chemistry is used in our everyday lives and it has a role in even the smallest of our daily items. Understanding basic chemistry is essential for understanding the effects of chemicals on the environment and can help you make day-to-day decisions that affect your life. Chemistry is important because everything, just like perfume, is made of chemicals. Thank you for listening to our TED Talk.